Long before touchscreens, hydraulics, and digital diagnostics, there were machines built with steel, steam, cables, and sheer endurance, and some of them never stopped working. Scattered across rail yards, mines, quarries, and museums are excavators so old they predate modern construction itself, yet still stand operational today. They were never designed to be temporary. They were built to dig relentlessly, survive brutal conditions, and outlast the men who built them. This is not a story of sleek innovation, but of stubborn longevity. From steam shovels that reshaped continents to mechanical giants that refused retirement, these machines are living fossils of industry. Otis steam shovel, the machine that dug the modern world. The Otis steam shovel stands at the very beginning of modern earth-moving, a machine that quite literally reshaped the physical world. Invented in the 1830s by American engineer William Otis, this steam-powered excavator transformed digging from a slow, labor-intensive process into an industrial operation. Before its arrival, large-scale excavation relied almost entirely on human labor, animals, and simple tools. The Otis steam shovel changed that equation forever. William Otis patented his design in 1839 at just 26 years old. His machine used a steam engine to power a system of winches, cables, and gears that controlled a hinged boom and bucket. Compared to manual digging, the shovel could move massive quantities of earth with unprecedented speed and consistency. Although crude by modern standards, its mechanical logic established the foundation for all excavators that followed. The impact of the Otis steam shovel was immediate and far-reaching. Railroads were expanding rapidly across the United States, and the shovel made it possible to cut through hills, carve embankments, and dig foundations at a scale previously unimaginable. Major canals, urban infrastructure, and early industrial projects depended on machines derived from Otis's original concept. In many ways, the shovel became a catalyst for the Industrial Revolution's second phase, enabling cities and transportation networks to grow outward and upward. Despite its revolutionary nature, the original Otis steam shovel had limitations. It was large, slow to relocate, and required skilled operators and constant maintenance. Steam boilers demanded water, fuel, and careful oversight, making operation complex and sometimes dangerous. Yet, even with these drawbacks, the shovel outperformed traditional methods so decisively that there was no turning back. Tragically, William Otis did not live to see the full impact of his invention. He died of typhoid fever shortly after receiving his patent. Nevertheless, his design lived on through companies such as Otis Tufts and later manufacturers who refined and scaled the steam shovel concept. Over time, these machines grew larger, more powerful, and more reliable, becoming essential tools for mining, construction, and large public works. Remarkably, several Otis-style steam shovels survive today, preserved in museums and occasionally operated by enthusiasts and historical engineering groups. Some remain mechanically functional, a testament to the durability of early industrial craftsmanship. More than a historical curiosity, the Otis steam shovel represents the moment humanity learned to dig on an industrial scale. It is no exaggeration to say that modern skylines, railroads, and canals trace their origins back to this single, transformative machine. Marion, 6360, the Captain, America's century-old giant. The Marion 6360, known as the Captain, is one of the largest and most enduring symbols of America's industrial age, a mechanical giant built not for spectacle, but for relentless, decades-long labor. Constructed in 1908 by the Marion Steam Shovel Company of Ohio, this colossal steam-powered excavator was designed to move earth on a scale that few machines of its era could rival. More than a century later, it remains a powerful reminder of how early engineering ambition shaped modern industry. Standing over 5 stories tall and weighing more than 1,200 tons, the Marion 6360 was built during a period when raw mechanical strength was the primary solution to large-scale excavation. Powered by massive steam engines, the machine operated through an intricate system of cables, drums, and gears. Its bucket alone could scoop dozens of tons of material in a single pass, making it ideal for mining, quarrying, and major infrastructure projects. The Captain earned its nickname not through marketing, but through reputation. It was deployed in iron ore operations where reliability mattered more than speed. Unlike smaller excavators that came and went, the 6360 was designed to remain in place for years, sometimes decades, steadily removing mountains of material day after day. Its slow, deliberate movements reflected the engineering philosophy of the time: durability over efficiency, mass over mobility. Operating the Marion 6360 required a skilled crew. Steam pressure had to be carefully managed, mechanical components constantly monitored, and repairs performed on site. Breakdowns were costly, but the machine's robust construction meant that most issues could be fixed rather than replaced. This maintainability is one reason the 6360 outlasted many newer machines built with lighter materials and tighter tolerances. As diesel and electric excavators emerged in the mid-20th century, giants like the Marion 6360 became increasingly rare. Their immense size made relocation expensive, and their steam systems demanded resources modern operators no longer wished to manage. Yet, the Captain avoided scrapping, preserved not only as a relic but as a functioning example of early heavy machinery engineering. Today, the Marion 6360 stands as a monument to an era when engineers solved problems by building bigger, stronger, and more permanent machines. It represents the peak of steam-powered excavation and the mindset that built America's mines, railways, and industrial foundations. Long after newer technologies replaced it, the Captain remains. Silent, massive, and enduring proof that some machines were built not just to work, but to last for generations. Rustin and Hornsby steam excavator, Britain's industrial workhorse. The Rustin and Hornsby steam excavator stands as one of Britain's most dependable industrial machines, a workhorse that helped drive the nation through the height of its industrial and imperial power. Built in the late 19th and early 20th centuries by the Lincoln-based engineering firm Ruston, Proctor and Company, later known as Rustin and Hornsby, these steam excavators became synonymous with reliability, adaptability, and sheer mechanical endurance. Unlike the massive, specialized steam shovels used for single megaprojects, Rustin and Hornsby excavators were designed for versatility. They were deployed across rail construction, canal maintenance, dockyards, mining operations, and urban infrastructure projects throughout Britain and the wider empire. Wherever earth needed to be moved efficiently and repeatedly, these machines were likely to be found. Their relatively compact size compared to American steam giants allowed them to operate in tighter spaces, making them invaluable for civil engineering rather than just open-pit excavation. Technically, the machines reflected practical British engineering philosophy. Powered by coal-fired steam boilers, Rustin and Hornsby excavators used robust winches, chain drives, and cable-operated booms to control digging and dumping motions. The emphasis was not on speed, but on steady, predictable output. Operators could work for long shifts with minimal downtime, provided the boiler was maintained and the mechanical systems were kept properly lubricated. One of the defining strengths of these excavators was their durability. Built from thick steel plates and heavy cast components, they were designed to withstand harsh working conditions, poor weather, and continuous operation. Repairs were straightforward and could often be carried out in the field, an essential feature at a time when spare parts and specialized technicians were not always readily available. This simplicity contributed directly to their remarkable longevity. As internal combustion engines and later hydraulic systems emerged, steam excavators gradually fell out of favor. They required trained crews, constant fuel and water supplies, and careful boiler management. Yet, many Rustin and Hornsby machines refused to disappear. Some remained in service well into the mid-20th century, long after steam power had been declared obsolete. Others were preserved by contractors who valued their reliability over modern complexity. Today, surviving Rustin and Hornsby steam excavators can still be found in museums and heritage railways across the United Kingdom, and a few are even maintained in operational condition. When their boilers are fired and their mechanisms brought back to life, they offer a vivid demonstration of industrial Britain at work. More than just construction equipment, the Rustin and Hornsby steam excavator represents an era when machinery was built to endure decades of hard labor. It was not flashy, experimental, or revolutionary, but it was dependable. And in the story of industrial progress, dependability is often what truly shapes the world. Bucyrus steam shovel, the backbone of early megaprojects. The Bucyrus steam shovel was one of the most influential machines of the early industrial age, a cornerstone of the massive infrastructure projects that defined the late 19th and early 20th centuries. Built by the Bucyrus Company of Ohio, these steam-powered excavators became synonymous with large-scale earth-moving, providing the muscle needed to reshape landscapes on a previously unimaginable scale. Founded in 1880, Bucyrus quickly established itself as a leader in heavy excavation equipment. Its steam shovels were engineered for demanding, long-term projects where reliability mattered more than speed. Powered by coal-fired boilers, Bucyrus machines used heavy-duty cables, drums, and booms to dig, lift, and dump enormous volumes of material. Their design emphasized strength, stability, and continuous operation, qualities essential for projects measured in years rather than months. The Bucyrus steam shovel earned its reputation on some of history's most ambitious undertakings. Most famously, Bucyrus equipment played a central role in the construction of the Panama Canal. Massive Bucyrus shovels worked relentlessly in brutal heat and torrential rain, cutting through rock and clay while helping to overcome landslides and flooding. Without these machines, the canal's completion would have been far slower, more dangerous, and potentially impossible with the technology of the time. Beyond the Panama Canal, Bucyrus steam shovels were deployed across railroad expansions, mining operations, harbor construction, and urban development. As cities grew upward and outward, Bucyrus machines dug foundations, subway lines, and utility corridors that formed the skeleton of modern infrastructure. They enabled projects that demanded precision as well as power, proving that steam excavation could be both forceful and controlled. Operating a Bucyrus steam shovel required skill and coordination. Crews managed boiler pressure, controlled multiple winches, and carefully synchronized movements to avoid mechanical strain. While these machines were complex, they were also remarkably serviceable. Components were oversized, access was straightforward, and repairs could often be made on site. This practicality extended their working lives well beyond what many later machines achieved. As diesel engines and electric motors replaced steam in the mid-20th century, Bucyrus shovels gradually disappeared from active service, yet many were not scrapped immediately. Their solid construction allowed them to remain operational for decades, and several survive today in museums or private collections, some still capable of digging under steam power. The Bucyrus steam shovel represents more than a piece of machinery. It symbolizes the era of mega-projects, when nations reshaped geography through industrial will. These machines formed the backbone of early modern construction, proving that with enough steel, steam, and determination, even the largest obstacles could be moved. P&H Model 206, the electric excavator that refused to retire. The P&H Model 206 stands as a quiet testament to durability, a machine that proved electric power could rival and outlast its steam and diesel predecessors. Built by Harnischfeger Corporation, better known as P&H, this electric excavator emerged in the early 20th century at a time when most heavy machinery still relied on boilers or internal combustion engines. While it lacked the drama of steam giants, the Model 206 earned its reputation through something far more valuable: longevity. Introduced as part of P&H's growing line of electrically powered shovels, The Model 206 was designed for industrial environments where steady power and continuous operation mattered more than mobility. Powered by external electrical supply rather than onboard fuel, it eliminated boilers, fireboxes, and fuel logistics entirely. This made the machine cleaner, quieter, and significantly simpler to operate, especially in mines and quarries already equipped with electrical infrastructure. Mechanically, the 206 reflected P&H's emphasis on precision engineering. Heavy-duty electric motors drove the hoist, swing, and crowd motions through robust gearing and cable systems. Compared to steam shovels, the electric controls allowed smoother, more responsive operation, reducing mechanical shock and wear. Operators could perform precise digging cycles repeatedly, shift after shift, without the fluctuations associated with steam pressure or fuel quality. The Model 206 found widespread use in mining, aggregate production, and large industrial excavation projects. Its reliability made it particularly valuable in operations where downtime translated directly into lost revenue. With fewer moving parts than steam-powered machines and no combustion system to maintain, the 206 often ran for years with only routine servicing. When components did wear out, they were designed to be repaired or replaced rather than discarded. As diesel and hydraulic excavators gained popularity after World War II, many electric shovels were retired. Yet the P&H 206 proved unusually resistant to obsolescence. In fixed-location operations where electrical power was readily available, there was little incentive to replace a machine that continued to perform its job efficiently. Some units remained in service for several decades, quietly outworking newer designs that promised more flexibility but delivered less endurance. Part of the Model 206's survival can be traced to P&H's build philosophy. Frames were heavily reinforced, motors were oversized for longevity, and systems were engineered with generous tolerances. These choices made the machine heavier and less portable, but extraordinarily robust. In an era increasingly focused on planned replacement cycles, the 206 belonged to an older mindset, one that assumed machines should last as long as possible. Today, surviving P&H Model 206 excavators are rare but revered. Some remain preserved at former industrial sites or in collections dedicated to heavy equipment history. They represent a pivotal transition from steam to electric power and demonstrate that technological progress does not always mean constant replacement. The P&H 206 refused to retire because it never needed to. It simply kept working. Lima steam shovel, built before diesel took over. The Lima steam shovel represents a critical moment in excavation history. Built at the peak of steam power just before diesel engines transformed heavy machinery forever. Manufactured by the Lima Locomotive Works of Ohio, a company better known for its steam locomotives, these shovels carried railroad-grade engineering into the world of earth-moving. The result was a machine designed for relentless work, built with the same philosophy that powered trains across continents. Introduced in the early 20th century, Lima steam shovels were intended for large infrastructure and industrial projects that demanded endurance rather than speed. Their coal-fired boilers powered heavy winches and cable systems that controlled the boom, dipper stick, and bucket. Everything about the design emphasized strength, thick steel plating, oversized gears, and components built to withstand years of constant stress. Lima applied locomotive standards to excavation, assuming the machine would spend most of its life operating at full load. These shovels became common sights on railroad expansions, mining sites, and major construction projects across North America. As tracks pushed into remote regions, Lima steam shovels followed, carving cuts, leveling grades, and moving massive volumes of earth. Their ability to work continuously for long shifts made them indispensable during an era when time and manpower were both costly. In many projects, progress was measured by how fast a Lima shovel could dig. Operating a Lima steam shovel was demanding and required a skilled crew. Boiler pressure had to be maintained carefully, fuel and water constantly replenished, and mechanical systems monitored to prevent failure. Yet, despite their complexity, these machines earned a reputation for reliability. When problems occurred, they were usually mechanical rather than systemic, allowing crews to repair them on site with basic tools and experience. The rise of diesel power in the 1920s and 1930s marked the beginning of the end for steam excavation. Diesel engines were easier to start, required smaller crews, and offered greater mobility. Compared to these newer machines, steam shovels were labor-intensive and slow to relocate. Even so, many Lima shovels remained in service well into the diesel era. Their sheer durability made replacement difficult to justify when budgets were tight and performance remained adequate. Today, surviving Lima steam shovels are preserved in museums and heritage collections, with a few still capable of operating under steam. They stand as artifacts of a transitional era, when steam power reached its mechanical peak just before being overtaken by internal combustion. The Lima steam shovel was not obsolete when diesel arrived. Built before diesel took over, it embodies a time when machines were designed to endure harsh conditions and long service lives. In doing so, it helped lay the groundwork for modern excavation, one bucket of earth at a time. Osgood steam shovel, a survivor of the steam age. The Osgood steam shovel stands as one of the quieter survivors of the steam age, less famous than Bucyrus or Marion machines, yet equally vital to the rise of mechanized excavation. Built by the Osgood Company in the late 19th and early 20th centuries, these steam shovels were workmanlike machines designed for reliability, not spectacle. They earned their place through steady performance on the kinds of projects that shaped everyday industrial life. Osgood steam shovels were typically smaller and more compact than the towering American giants that dominated headline projects. This made them especially well-suited for railroad construction, municipal works, quarry operations, and smaller mining sites. Where space was limited or budgets were tighter, Osgood machines filled the gap, providing mechanical excavation power without the immense logistical demands of larger steam shovels. Technically, the design followed classic steam shovel principles. Coal-fired boilers supplied power to winches and drums that controlled the boom, dipper stick, and bucket through a network of cables. The machines were deliberately overbuilt, with thick steel frames and simple mechanical layouts that prioritized durability over refinement. While they lacked advanced features, their straightforward construction made them easy to understand, operate, and repair in the field. What truly defined the Osgood steam shovel was its longevity. Many units remained in service long after steam power began to decline, simply because they continued to work. Contractors who owned them saw little reason to replace a machine that could still move earth reliably day after day. Spare parts could often be fabricated locally, and maintenance relied more on mechanical skill than specialized components. This practicality allowed Osgood shovels to survive well into the early diesel era. Operating an Osgood shovel required experience and coordination. Boiler pressure had to be managed carefully, and the operator needed a strong sense of timing to coordinate hoisting, swinging, and dumping motions. Despite this, crews often developed deep familiarity with their machines, treating them less as equipment and more as long-term partners on the job site. As diesel and hydraulic excavators became dominant, most Osgood steam shovels were eventually retired. Their slower setup times and labor-intensive operation could not compete with newer technology. Still, a handful escaped scrapping. Some were preserved by companies that valued their history, while others survived simply because they were parked and forgotten rather than dismantled. Today, surviving Osgood steam shovels are rare, but their existence speaks volumes. They represent the backbone of everyday industrial excavation, the machines that did not make history books, yet quietly made history possible. As survivors of the steam age, Osgood shovels remind us that endurance, not fame, is often what allows a machine to stand the test of time. Menck and Hambrock M60, Germany's pre-war mechanical excavator. The Menck and Hambrock M60 represents a crucial chapter in European excavation history, standing at the crossroads between steam-era machinery and the rise of modern mechanical earthmovers. Developed in Germany during the interwar period, the M60 was a purely mechanical excavator, built before hydraulics and long before diesel power became dominant. It embodied German engineering priorities of precision, durability, and disciplined mechanical design. Founded in Hamburg in 1868, Menck and Hambrock had already earned a reputation for high-quality cranes and construction machinery by the early 20th century. The M60 emerged as part of the company's effort to modernize excavation without relying on steam boilers, which were increasingly viewed as cumbersome and inefficient. Instead, the excavator used mechanical drive systems powered by internal combustion engines, transmitting force through gearboxes, shafts, and cable-operated winches. The M60 was designed for versatility rather than sheer size. It was commonly employed in civil engineering, port construction, canal maintenance, and early road-building projects across Germany and neighboring countries. Its relatively compact footprint allowed it to operate in confined spaces where larger steam shovels were impractical. This made it particularly valuable for urban infrastructure work, where precision and control mattered as much as raw digging power. Mechanically, the M60 reflected careful engineering discipline. Its steel frame was heavily reinforced, and its moving components were built with generous tolerances to withstand continuous use. The cable-driven boom and bucket system allowed for controlled digging and accurate placement of material, while the mechanical simplicity of the drivetrain made field repairs manageable. Operators trained on the M60 often praised its predictable handling and robustness, even under demanding conditions. Unlike steam machines, the M60 could be started quickly and operated with a smaller crew. This reduced labor costs and improved deployment speed, key advantages as construction timelines grew tighter during the 1930s. Fuel efficiency and easier maintenance further increased its appeal, especially for contractors transitioning away from steam, but not yet ready for more complex hydraulic systems. The outbreak of World War II halted further development and production. Industrial priorities shifted toward military manufacturing, and civilian construction equipment became secondary. As a result, machines like the M60 never achieved the international recognition of later post-war excavators. After the war, rapid advances in hydraulics quickly rendered purely mechanical excavators obsolete. Despite this, several Menck and Hambrock M60 units survived well into the post-war reconstruction era. Their rugged build allowed them to remain operational during a period when resources were scarce and replacement machinery was unavailable. Some were used for decades before finally being retired. Today, the M60 stands as a reminder of a transitional era in excavation history. It represents the moment when engineering moved decisively away from steam, yet had not fully embraced hydraulics. As Germany's pre-war mechanical excavator, the Menck and Hambrock M60 proved that thoughtful design and mechanical reliability could bridge generations of technology and endure far longer than expected. Bucyrus-Erie 120B, still digging, decades after its prime. The Bucyrus-Erie 120B is a powerful example of industrial machinery built to outlast its era, an excavator that continued working long after newer technologies claimed to replace it. Introduced in the mid-20th century, the 120B belonged to a generation of heavy cable-operated excavators, designed during a time when durability and service life mattered more than rapid obsolescence. For decades, it proved that sound mechanical engineering could remain relevant far beyond its intended lifespan. Developed by Bucyrus-Erie, one of the most respected names in excavation history, the 120B was engineered for demanding work in mining, quarrying, and large-scale construction. Unlike earlier steam shovels, it was powered by diesel or electric systems, eliminating boilers while retaining the proven cable and drum digging architecture. This combination gave operators greater reliability and flexibility without abandoning the rugged mechanical principles that had defined earlier machines. The 120B was valued for its balance of size and strength. Large enough to move substantial volumes of earth, yet compact enough to be relocated more easily than giant draglines, it became a favorite on long-term job sites. Its boom, hoist, and swing systems were heavily reinforced, allowing it to operate continuously under high loads. Many units worked for years in the same pit or quarry, cycling through countless digging operations with minimal structural fatigue. One of the key reasons the 120B endured was its serviceability. Components were accessible, systems were understandable, and repairs could often be performed on site. Unlike later hydraulic machines that depended on complex seals and high-pressure systems, the 120B relied on cables, gears, and motors that could be inspected visually and maintained incrementally. When parts wore out, they were replaced, not redesigned. This philosophy extended the machine's working life far beyond industry expectations. As hydraulic excavators gained dominance in the 1970s and 1980s, machines like the 120B were considered outdated. Hydraulics offered faster cycle times, smoother operation, and greater versatility. Yet in many operations, the Bucyrus-Erie continued digging. Owners saw little reason to retire a machine that still performed reliably, especially in environments where brute strength and consistency mattered more than speed. In some cases, the 120B remained active for half a century or more. Even when no longer used daily, many units were kept operational as backup machines or reassigned to secondary tasks. Their continued presence on job sites became a quiet testament to the longevity of mid-century industrial design. Today, surviving Bucyrus-Erie 120B excavators are increasingly rare, but their legacy is clear. They represent a time when machines were built to work indefinitely, not until the next upgrade cycle. Still digging decades after their prime, the 120B stands as proof that reliability can be the most advanced feature of all. Thew automatic shovel, a 19th century machine still at work. The Thew automatic shovel occupies a remarkable place in excavation history as one of the earliest mechanically driven shovels, and one that, astonishingly, outlived the century that created it. Developed in the late 19th century by the Thew Automatic Shovel Company of Ohio, this machine represented a decisive step away from purely steam-driven excavation and toward more efficient, mechanically automated earth-moving. Introduced in the 1890s, the Thew shovel was revolutionary for its time. While many steam shovels relied heavily on manual coordination and external winches, the Thew design integrated its mechanisms more tightly, allowing smoother, more automated digging cycles. It used steam power initially, but its defining feature was the way motion was mechanically synchronized through internal gearing and controls, reducing operator workload and increasing consistency. The Thew automatic shovel was particularly well suited for railroad construction, municipal works, and medium-scale excavation projects. Its relatively compact size allowed it to work in confined spaces such as rail cuts, urban foundations, and utility trenches, areas where massive steam shovels were impractical. This flexibility made it a popular choice for contractors who needed dependable excavation without the expense and logistics of larger machines. Durability was central to the Thew shovel's design. Built from heavy steel plate and cast components, it was engineered to endure constant stress and harsh working conditions. The mechanical systems were simple, robust, and accessible, allowing crews to perform maintenance and repairs directly on site. In an era when spare parts could take weeks to arrive, this self-sufficiency was invaluable. What truly sets the Thew automatic shovel apart is its longevity. Some units remained in service well into the 20th century, long after newer steam, diesel, and electric excavators had entered the market. In certain industrial and municipal roles, these shovels continued operating because they were already paid for, mechanically sound, and familiar to their crews. as long as they could dig, there was little incentive to replace them. Even as excavation technology advanced rapidly, the Thew shovel proved that early automation concepts were sound. Its mechanical efficiency reduced wear, improved cycle consistency, and extended service life. These qualities allowed it to bridge multiple technological eras: steam, early combustion engines, and eventually full mechanization. Today, surviving Thew automatic shovels are rare, but a few remain preserved in museums or private collections, with some still mechanically operable. Their continued functionality is not accidental. It is the result of thoughtful engineering and conservative design choices made more than a century ago. The Thew automatic shovel is more than a historical artifact. It is proof that the foundations of modern excavation were laid in the 19th century, and laid so well that some of those machines refused to stop working. Caterpillar 225, the early hydraulic that changed everything. The Caterpillar 225 represents a turning point in excavation history, the moment when hydraulics began to decisively replace cables, drums, and brute mechanical force. Introduced in the late 1960s, the 225 was among Caterpillar's first successful large hydraulic excavators, arriving at a time when much of the construction industry still relied on cable-operated machines. What it offered was not just a new power system, but an entirely new way of working. Before hydraulics became dominant, excavators depended on complex arrangements of winches, clutches, and steel cables. These systems were strong but rigid, requiring skilled operators to manage momentum and timing. The Caterpillar 225 changed that relationship between operator and machine. Its hydraulic cylinders provided smooth, precise, and instantly controllable movement, allowing the boom, stick, and bucket to operate independently and simultaneously. This dramatically improved accuracy, efficiency, and safety on the job site. Powered by a reliable Caterpillar diesel engine, the 225 delivered hydraulic force that was both consistent and adaptable. Operators could feather movements, make fine adjustments, and work effectively in confined spaces, tasks that were difficult or impossible with cable machines. Trenching, grading, and foundation work became faster and more controlled, reshaping expectations for productivity across the industry. The machine's impact extended beyond performance. Maintenance requirements were fundamentally different. While early hydraulics introduced new challenges, hoses, seals, and fluid management, the overall system reduced mechanical complexity. Gone were many of the heavy rotating drums and exposed cables that demanded constant inspection. For contractors, this meant fewer breakdowns and easier training for operators transitioning from older equipment. The Caterpillar 225 quickly proved its value across construction, utilities, and light mining operations. Its size made it versatile enough for urban work, yet powerful enough to handle demanding excavation tasks. Many units remained in service for decades, especially with proper maintenance, as the basic hydraulic architecture proved remarkably durable. In some regions, Caterpillar 225 excavators are still operating today, long after newer models have come and gone. Equally important was the precedent the 225 set within Caterpillar itself. The success of this machine accelerated the company's full commitment to hydraulic excavator development, shaping generations of equipment that followed. What was once experimental quickly became standard, and cable machines faded into niche roles and eventual retirement. The Caterpillar 225 did not merely improve excavation, it redefined it. It marked the moment when control replaced momentum, precision replaced brute force, and hydraulics became the industry standard. As an early hydraulic excavator still remembered and, in some cases, still working, the 225 stands as the machine that changed everything. Koehring 205, when mechanical excavators ruled construction. The Koehring 205 stands as a representative of an era when mechanical excavators dominated construction sites, long before hydraulics became the industry standard. Built by the Koehring Company of Wisconsin in the mid-20th century, The 205 embodied the final refinement of cable-operated excavation, a machine designed for strength, reliability, and continuous hard labor rather than finesse or automation. During its prime, the Koehring 205 was a common sight on large construction and infrastructure projects across North America. It was powered by a diesel engine that drove a system of drums, clutches, and steel cables controlling the boom, hoist, and bucket. This mechanical arrangement demanded skill and experience from operators, who relied on timing, momentum, and coordination to execute efficient digging cycles. In capable hands, the 205 could move enormous volumes of earth with impressive consistency. The design philosophy behind the 205 was straightforward and practical. Its frame was heavily built, its components oversized, and its systems deliberately simple. Koehring engineers assumed the machine would operate in harsh environments for long periods with minimal downtime. As a result, the excavator was easy to service, with accessible mechanical parts that could be inspected and repaired on site. This ruggedness made it especially popular with contractors working in remote areas where reliability mattered more than speed. Versatility was another strength of the Koehring 205. It could be configured for shovel, dragline, or crane duties, allowing a single machine to perform multiple roles on a job site. This adaptability made it valuable during an era when equipment fleets were smaller, and machines were expected to justify their cost through broad utility. From road construction and dam projects to quarrying and general excavation, the 205 proved capable across a wide range of tasks. As hydraulic excavators began to emerge in the late 1960s and 1970s, machines like the Koehring 205 were increasingly labeled obsolete. Hydraulics offered faster cycle times, smoother operation, and reduced operator fatigue. Yet many Koehring 205 units refused to disappear. Contractors who owned them often kept them working, citing their durability and the familiarity of crews trained on mechanical systems. In many cases, the machines were already paid for, reliable, and perfectly suited to the work required. Some Koehring 205 excavators remained active for decades, far beyond their expected service life. Even after retirement, many were preserved as backups or repurposed for secondary jobs. Their longevity reflected an era when construction machinery was built to endure rather than to be replaced. Today, the Koehring 205 is remembered as a symbol of mechanical excavation's peak. It represents the last generation before hydraulics reshaped the industry, and a time when mastery of machinery depended as much on human skill as on engineering innovation. Marion 7400. Dragline, the mining giant that time forgot. The Marion 7400 dragline stands as one of the most imposing mining machines ever built, a colossal reminder of an era when scale was the primary solution to industrial demand. Constructed by the Marion Power Shovel Company in the mid-20th century, the 7400 was designed specifically for surface mining operations that required moving unimaginable volumes of overburden day after day. While lesser machines came and went, the 7400 was built to dominate landscapes for generations. At its core, the Marion 7400 was a walking dragline, an excavator so massive it could not rely on tracks or wheels. Instead, it moved by lifting its own weight and walking across the ground on enormous shoes. This slow but deliberate mobility allowed it to reposition across open pit mines without relying on roads or rail systems. Once in place, the machine could operate continuously, swinging its long boom and massive bucket in a steady rhythm that defined large-scale mining for decades. The dragline's bucket alone weighed tens of tons and could scoop vast amounts of earth in a single pass. Its reach allowed it to strip away layers of soil and rock, exposing coal or minerals beneath with unmatched efficiency. Powered by electric motors rather than diesel engines, the 7400 relied on external power supplies, making it both energy-intensive and remarkably consistent in output. As long as electricity flowed, the machine worked. Operating the Marion 7400 required a specialized crew and careful coordination. From the operator's cab high above the ground, precise control was essential to manage the enormous forces involved. Maintenance teams worked constantly to inspect cables, motors, and structural components, ensuring the dragline could endure the stresses of continuous operation. Despite its complexity, the machine was engineered for longevity, with reinforced structures and conservative design margins. As mining technology evolved, machines like the 7400 gradually fell out of favor. Newer draglines and alternative excavation methods offered improved efficiency, automation, and reduced operating costs. The sheer size of the 7400 made relocation expensive, and environmental regulations began to reshape mining practices. One by one, these giants were shut down, dismantled, or abandoned where they stood. Today, the Marion 7400 is rarely remembered outside mining history circles, yet its impact remains undeniable. It represents the peak of mechanical ambition in surface mining, a time when engineers solved problems by building bigger, stronger, and more permanent machines. The Marion 7400 may no longer move Earth, but it stands as a forgotten titan, proof that for a time, industry reshaped the planet using machines of truly monumental scale. Ruston-Bucyrus, 19RB, an excavator, older than modern earth-moving. The Ruston-Bucyrus, 19RB, stands as a living link between the birth of mechanized excavation and the modern earth-moving industry. Built in the early decades of the 20th century through a partnership between Britain's Rustin and Hornsby and America's Bucyrus Company, the 19RB was designed at a time when powered excavation itself was still a novelty. Remarkably, some examples of this machine have survived long enough to outlive the very definition of modern construction equipment. The 19RB was a cable-operated excavator, relying on steam power in its earliest forms and later adapted to diesel or electric drives. Its operation centered on a system of winches, drums, and steel cables that controlled the boom, dipper, and bucket. By modern standards, the process was slow and labor-intensive, but for its time, it represented a dramatic leap forward. Tasks that once required hundreds of workers with shovels could now be completed by a small crew operating a single machine. What set the Ruston-Bucyrus 19RB apart was its balance of size, strength, and practicality. It was large enough to handle serious excavation work, railways, docks, canals, and municipal infrastructure, yet compact enough to be transported and deployed without extraordinary logistics. This made it a favorite across Britain, Europe, and parts of the Commonwealth, where infrastructure expansion demanded reliable machines rather than experimental designs. Durability was the machine's defining trait. The 19RB was built with thick steel plating, oversized mechanical components, and conservative engineering tolerances. Ruston-Bucyrus assumed these machines would work for decades, and they designed accordingly. Maintenance was straightforward, and most repairs could be carried out on site using basic tools and skilled labor. In an era before planned obsolescence, longevity was an expectation, not a bonus. As hydraulic excavators emerged after World War II, cable machines like the 19RB were gradually sidelined. Hydraulics offered faster cycle times, smoother control, and reduced crew requirements. Yet many 19RB units refused to disappear. In quarries, industrial yards, and heritage operations, they continued working simply because they still could. Owners often found that replacing them offered little practical advantage when the old machine remained functional. Today, surviving Ruston-Bucyrus 19RB excavators are rare, but a handful remain preserved, and in some cases operational. Their continued existence is extraordinary. These machines were already old when modern earth-moving standards were established, yet they endured into an age of computers, automation, and digital controls. The Ruston-Bucyrus 19RB is more than an antique excavator. It is proof that the foundations of modern construction were laid by machines built to last. Machines so robust that they quietly crossed centuries while still doing the job they were designed to do.